Back. So today we start with AP, arithmetic progressions. Actually the chapter is AP and GP. So in one video, which is this video, or maybe two videos, I will check about it, the time limit, I will do AP and GP. So let's begin. So let's start with the chapter now. So here I have written what you call a series. It's actually not technically a series, but at this like class 10 you know as this as a series. So like if I write, and obviously there has to be some pattern. This series has to have some pattern, any pattern. Like say how to write this series. Okay, let's say 1. So then let me write 3, 7, 15 and so on. What is the pattern in this? You'll see the pattern is nothing but into 2 plus 1. Here also you'll see into 2 plus 1. Here also you'll see into 2 plus 1. So this is one pattern that this series is following. So I can say what? That A2 has some relation with A1. Okay, this may be also sometimes maybe with two things. This is actually not in the syllabus. These type of like series can be formed into a recurrence relation. No need of that now. So let's say we have this famous series, if you know, 1 2 it's not series actually, 2 3 5 8. You know what this is? This is called the Fibonacci sequence, or for your age now, it's for like class 10, it's okay to be saying that it is a series, Fibonacci series. So you can see what is the logic behind that. A3 will be A2 plus A1. Same way A4 will be what? A2 plus A3 plus A2, meaning what? Everything will be the sum of two terms before it. This will be the sum of this, this will be the sum of this will be the sum of this, this will be the sum of this, like this. Okay, so now actually let us tell you what is arithmetic progression. Any progression, okay, the quantities are said, this is the actual definition, quantities that are said to be in arithmetic progression increase or decrease by a common difference. Hear this word. So let's say I have this sequence 3 7 11 15 19, and you see what is the difference between them. It's 4 4 4 4. So when there is a difference that is common for each and every term, that is called my series, AP. That kind of series is called AP. As you can see here, it is increasing. It's increasing the value. We can also have such a value like, let's say 8 2 minus 4 minus 10. As you can see here, it is decreasing by 6 in each term. It is decreasing by 6. So it can be also in decreasing or in the negative manner. Okay, you understand? This is the basic meaning of AP. So actually let's give you some series and tell me if they are APs or not. Okay, now if I ask you the question that which of these are APs, as you can see here, the difference is what? 19 plus 19. What is the difference here? As you can see, again it's plus 19. So as you can see, there is a difference that is common between the two. This is a question. Okay, so before I solve a question, always pause the question and try to solve that. Okay, and here you will see the common difference is nothing but 17. And what is the common difference? Not common difference, what is the difference here? It is nothing but 11. So are they common with each other? No. So that this part is not an AP, this one is an AP. Understand very clearly. So now let's try to do the next part, that is how to find the nth term of an AP. Understand this very clearly. So now let's say I have a series, let's say starting with u1, u2, I'm not giving a because you'll understand later, u3 till un. Okay, not the United Nations, just UN. So let's say these are in AP. Okay, so I can say what u2 I can write is u1 plus some common difference. As we have learned, see, u1 u2, there will be some common difference. Let's say that is d. Let's say that's d. Okay, and we'll consider one thing also, that u1's value is a. Okay, so I can write this as, one second, I can write this as, let's say, a plus d. Next term, let's say u3, that will be what, u2 plus again d, because see, u2 u3, the difference will be common between all those. So u2 was what, a plus d, so a plus 2d. So if you see the series now clearly, the series is forming to a plus d, then the next term will be a plus 2d. One second, why is my device not working? Yes, it's working now. A plus 3d and so on. Now if you see the nth term that we need to find, nth term, very clearly you try to understand this, very clearly you understand this. In the first term, meaning this term, in the first term, what is the coefficient of d? Let's say this thing expression, as you can see, let me tell it that this expression can be written as the some form of a into some bd. Okay, bd. At the first position, what is the value of b? 0. Here b equal to 0. Here next term it is coming b equal to 1, and here next is coming b plus equal to 2 and b equal to 3. Now if you can see very clearly, at first term it is getting 0, at second term it is getting 1, at third term it is getting 2, at fourth term it is getting 3. So I can say b at nth term will get exactly -1, n minus 1. So my tn, or here nth term means the last term, the nth term, whatever you say, or my un will be nothing but a plus n minus 1 into d. A very important formula, understand this very clearly. Okay, if you can go back and redo this, because this is a very important formula. So let's do some sums about this formula applying, because maths without practice is nothing. So I have actually decided that this practice jams I'll not be doing. I'll do the sums inside this thing only, this practice thing we are doing now, this video we are doing now. Okay, so let's go on and do the sum then. So here I have the sum with me. So how many terms of this series must be taken to make 2008? Now analyze the sum. This is a type of tricky sum, you may say, for beginners at AP and GP. So 208 is nothing but my last term. That's the trick you have to understand. So I have to do what? See this, 12, 16, 20, so on, 2008. How many terms of the series? Meaning what? I have to find the number of terms. Number of terms, that is nothing but my n. My a is given here, and the difference is what? You can easily find out. 16 minus 12 is nothing but 4 is my d. I found everything. So my d becomes here 4, a becomes 12. So what do I know? My last term, meaning, now see this, my last term Pn is equal to a plus n minus 1 d. What was my last term? 2008. And what was my initial term? Let's say a in this case. One second. Yes, it was 12, and this one will be n minus 1 into what was the different 4. I'll take this side. 4 into n minus 1 is equal to how much? 196. If I cut 196 with 4, it comes out to be, I forgot maths, I guess so n minus 1 will become what? 4, then 3, 49. So n will become nothing but 50. My answer is 50. Always try to do this sums pausing. Okay, pause the video and then do that. Okay, don't just start off. Okay, so let's move on to the next sum then. This is a little bit tricky sum if you want to see, and you have to visualize it. Use the formula as well. I'm giving you 5 seconds. You can pause the video and solve it. Okay, 1 2 3 4 5. Let's begin with the sum. And so this is my first information. One second. Main information is this and this. This is my information that I will going to use. The pth term of an AP is Q, and you can see that qth term is P, meaning that it is the same AP. So I can say what? A, the initial term being A, into pth term. So P minus 1 into D is equal to Q, because the pth term is the Q and the qth term is P, meaning A plus Q minus 1 into D is equal to P. Let's say this is equation 1 and this is equation 2. I'll do what? 1 minus 2, meaning I'll difference the equation. So what it will be? A plus, one second, A plus PD minus D minus A minus QD plus D is equal to Q minus P. A gets cut, D gets cut. So what do I have? D into P minus Q is equal to minus of Q minus P. See, Q minus P can be written as minus of P minus Q. This was a crucial step, CS, crucial step. Okay, now I can do what? D is nothing but P minus Q minus P minus Q minus P minus Q. It becomes minus 1. So D equal to minus 1. This was my first major breakthrough. I have to do to complete the sum. Second thing is that if I know D, I can substitute the value of D in any equation and find the value of A. So Q will be equal to A plus P minus 1. This was my first equation, if you can remember, and D is what? Minus 1. So I can write what? A is equal A minus P plus 1 is equal to Q. A equal to P plus Q minus 1. Understand? So I got the A value of A also. Major breakthrough part 2. Okay, now what I will do is that I have to find the mth term. If you remember clearly, I have to find the mth term. This is my needed thing. So mth term, how I will find is that mth term will be what? A plus m minus 1 into D. What is A? P plus Q minus 1. D is what? Minus 1. So my into minus 1. That will be nothing but P plus Q minus 1 plus, sorry, not plus, minus M plus 1. 1 gets cut. So my answer comes out to be P plus Q minus M. That's my answer. That's my answer. That's my answer. Done. So by this sum, what did I intend to teach you? Is that whenever there are sums like this, like many sums come, that there is one question that you will do later, I will surely give, that the mth term is 1 by n and the nth term is 1 by m. You have to find the term sum of m terms in 1 by n and sum of n terms is 1 by n. You have to find the sum of mn terms. That's a very good sum. So how to solve this kind of problem is that you have to always break down these problems into such said equations like this. We change the color. You have to break down into the equations that have been taught to you. Two equations. The sum equation we'll talk about later. This type of equation which you are learning today. Then you have to find the value of d. What I have done here, as you can see, you have to find the value of d, that is 1. I found it. Then you have to put the value of d and find the value of a. You know the value of a, d, sum done, put the value, done. You have finished the sum, full marks. This is the answer I got. Do like this. That's the procedure. So bye, and nothing else to say, and like, share and subscribe, and keep spreading the content.